Okay. I think it might have went. So let me go check it. Over on the page to make sure.
Are
Oh,
we just doing the
interesting.
YouTube live on this one?
Yeah, we're just
Okay.
gonna do
Okay.
YouTube live.
Okay. That way I know which one to jump to.
Yeah.
Oh,
So
perfect timing.
7:01. All right, let's go to. Cause I want to see if I can grab the link so I can go over it. There it is. Yay. Okay. We're live. It's there. So,
Yay!
all right, so we got. Let's see. I'm gonna grab the link and we're gonna put it over to Facebook, I guess. Let's go to. So anyway, we'll give it a couple minutes.
The usual, we'll let people wander in.
Yeah. So the Wander Inn. I think that's actually a name of a hotel that I stayed at.
The wander in?
Yeah, the
That's
Wander
kind of funny.
Inn. I mean, it's cute.
Wapesy just put extended warning geomagnetic K
Oh, did it?
index of 4 expected.
Oh.
Sorry, that's the
4.
most sarcastic I can be.
But that's what I'm saying. Perfect timing.
Yeah, perfect timing so we could talk about our current events and sunspots.
Mm-hmm.
So I put it in Michigan Aurora Chaser, so we'll see what happens there.
Great.
You guys can grab it if you want, but anyway, I will just start off here. So, hello, welcome in. I had to switch some stuff with the OBS, and we're here. I was only a minute late though, so I'll take that as a win. But today we're going to talk about current events first, and then we're going to go jump into sunspots. If you have ever had any questions about sunspots, what they are, I mean, what we know about them anyway.
There we go.
It should be fun little discussion, considering we had an interesting couple months with them, with the whole northern hemisphere kind of shutting off, and then the peak in August of the sunspots, so it should be fun. So anyway, we'll take it over and bring up the current events, talk about our current situation.
All right. And some
So
updates.
current update is where are we at with SDO, and finally that facility is dry. That's from official website, and they have level 0 data, which means we know that camera is actually looking at the sun, and we know that instruments are working just fine. But even for level 1 data, which is what people use for operations as opposed to research, that's going to take some time because the damage is extensive, and equipment has been ordered to replace what's been damaged. Data will not be lost, but it's going to take some time to repopulate everything. So be patient, and for the foreseeable future, if you are into looking at solar images for yourself, which you probably should, use alternative sources of data. We have plenty of it. They're not the same quality still, and it's not going to change until we have SDO back. All right. So that's one current event. Current event number 2, something hit us today, and trying to figure out what it was. We were at a bit of a loss because it may be a combination of a transient meaning it's a small, very slow CME that crawled over from the sun from one of the eruptions last week, probably in a very strange shape, and intermixed we decided it's still co-rotating interacting region. Co-rotating region means it made it more than one rotation from the coronal hole that survived. We are in the season where coronal holes actually can make it through more than one rotation. So that's probably what we're seeing. Trying to say for sure what it was, I don't think we can tell. But it created some nice conditions with fairly generous negative BC of -10. And this is where that KP of 4 came when European magnetometers were just entering the dusk, so very close to sunset. And if they had clear sky, they probably saw some aurora. As tradition goes for North America, everything changes when we have the sunset. So BZ is now all over the place. There is really nothing stable to talk about. There's not much of a forecast to talk about because BZ is oscillating. So that means fairly active aurora for higher latitudes if the sky is clear. And unfortunately, very sporadic activity for mid latitudes and very close to, well, for us, it's going to be Canadian border. That's going to be seeing it, but it's probably not going to be the case. And we'll talk about the weather shortly. But let's go to auroral electrojets. So this is magnetic activity. Again, this is all happening before we get into our nighttime. So very nice for the evening for Europe. Not so much for us. We're kind of looking again at some geomagnetic disturbance, as you can see from the auroral electrojets that are today. We're already in December 15th for UTC time, and that's basically our dark time. Not much is happening. So BZ may change. It's not going to be stable. Again, if this is coronal hole we're seeing, it's going to be all over the place. It may have some nice negative numbers, so it may charge to the point where we're gonna see something. And again, for those of you who are using ghost magnetometers, they are finally in the right area, but it really depends how close they're going to be to the onset of the substorm, whether or not they're going to pick up, because it's not going to be anything major or anything spectacular as of yet. Things change very quickly with coronal holes, and there's definitely ongoing enhancement because I think BT, so total magnetic field is around 10. That's pretty decent. So it's not a complete loss of the night for high latitudes. Probably going to see some nice activity. We're going to be looking at the very different conditions. So, Mary Beth.
Yeah. Oh yeah. My turn. We're gonna talk about weather because it's not it's not very pleasant. Let's say it that way. So let's see. I thought I had this.
I feel like you get the worst of that. So every time you go over weather, it's like weather's bad.
Hi, weather's bad. I think you can see my screen here.
Yes.
So I'll just bring up
Oh,
windy because windy is kind of a go-to. But we have a really nice low. I say that in quotes.
go to
Nice.
stream.
What's that?
No, you're good. Never mind.
Okay. Low pressure system that is descended upon the Great Lakes region. It has brought lots of mixed precipitation to us in the lower latitudes, more snow up north. I think the UP is sitting at around like 84 inches of snow so far, just in the past month, which is pretty substantial. It'll be good for the snowmobilers up there, that's for sure. But yeah, even if we had decent skies to deal with, or decent aurora to deal with, this is what we're looking at right here, and it's not super exciting. There is some clear, out the eastern ends of the Dakotas and Minnesota, but yeah, I don't. Obviously, it's. We still have like this big bright moon too, so it's not. All in all, this isn't the greatest week for this, unless you were way up north somewhere like in Fairbanks. We always talk about our friends in the high latitudes, and that seem to
Spoiled.
they're spoiled a little bit. But yeah, I could bring up the clouds, but it's just it's pretty nasty. So, and it's not going to get better. We're in that time of year. I always joke about living in the Great Lakes region. We're at the end of October. We never see the sun again until like March. Yeah, it's just a lot of it has to do with the lakes themselves. If these freeze over, we'll get more clear out of it. But the lake effect, they just make clouds. That's why last year was so particularly bad, is because the lakes didn't freeze. So you just always had this constant cloud machine making clouds. I don't know. Maybe we'll see it this year because we've had some really cold temperatures already. I mean, granted, it's warming back up, but I'm really hoping for some cold snaps. I'm sure like people yell at me for that, but I want to see the ice caves that haven't been accessible since 2015. So bring on the cold, please. Please.
With you there.
So anyway, that's all I got on weather. It's dismal, so we're gonna stop sharing on that, and we'll get into the bulk of our presentation today. We're gonna talk about sunspots, and we're gonna hand it over to Christian, our resident helio guy. This is his area.
The sunspots were something I got to go on initially, missing Aurora back in March of 2012 in Ohio, figuring out, okay, I really need to dive in and figure out what is causing Aurora because I'm tired of missing these shows. And you go all the way back to sunspots, and it turns out they have a very interesting behavior when they're around. So first off, there are literally spots on the sun. If you have not seen them yet, it's worth seeing. In fact, during the eclipse, I think one of our major things was, hey, put on the sunglasses, and there was, I think, a large one that was viewable, and if not, it was around the time period of the eclipse. You can actually see them with your eye. They're giant, several times Earth on average. You can stick, I want to say, 4 Earths in the average umbra in a sunspot. But they've been noted since literally 12th century BC. And it's pretty easy to get them on site, too, especially during the peak of the solar cycles. They had a method where they could just project the sun onto a giant board or piece of paper, but it would catch on fire, wall, something like that, and you could see the sunspots, and they would trace them out. So in these photos, these are actually traced photos of the sunspots, which is quite cool. Galileo also mentioned that they were visible, at least during his time when he was using telescopes. And then, of course, we had back in the 1800s when Carrington was viewing them as well. He was doing his routine and saw the flare, an actual flare in white light, while he was doing his copy of one of the bigger sunspots.
The infamous
but they've been around
Carrington event.
For the whole lifetime of the sun. Say again?
The infamous Carrington event.
The infamous Carrington event. These are just two cool diagrams that I like, well, especially the one from NSO. These are specific details of what sunspots look like up close. The black area is called the umbra of it, just like a shadow. The umbra is the darker part of a shadow. The penumbra is then the outer edges of the shadow that's not quite as dark. Although the reasoning that it's dark here is quite different than just the absence of light. Sunspots, well, if we want to dig in deep, there is a convective layer underneath the photosphere. So as you're going along a solar cycle, the magnetic field within the convective layer gets stronger and stronger until it starts bundling up and getting buoyant and floating up into the photosphere. When they poke out of the photosphere, it inhibits convection, which is what causes the sun to be so bright. This inhibition is what causes the dark spots to show up. The first photo showing these flux tubes as they start arising, you start having them poke out of the sun, and then you also have them coming back down, which is then the penumbra as they're coming back inward towards the sun. But the point is, black area here, umbra, the outer edges are called the penumbra, and generally there's ways to look at them to decide how complex they are. Now, I know a lot of people, especially the ones that are trying to at least follow somewhat with sunspot classifications, know the magnetic complexities. We always hear beta, beta gamma, beta delta gamma, whatever kind of combinations you want to make. That is just a representation of the magnetic field properties. That cannot be assessed based on the white light imaging alone. You need magnetogram data, which looks at the polarity of the magnetic field coming out of the sun towards the Earth or away from the Earth. So you have the alpha, which is just a unipolar spot. It's a single umbra that's around, has one polarity, and it's simple. These are not complex groups. Then you have a standard sunspot, beta. They have a positive area and a negative area. Nice and simple. But there's a distinction between them. You can draw a line and say this is the positive end, this is the negative end. And then you've got beta gamma, which is a lot less clear, in which case usually you have some sort of negative umbra mixed with your positive umbra, or vice versa. Hey, you got your negative and my positive, that kind of thing. And then there's just gamma, which I'll be honest, you do not see a gamma structure on its own very much. We just kind of adhere to beta gamma now. There's not really a need for just the gamma on its own. And then the delta spot, which is kind of the more complex one that most people look at for sunspots, where you have two opposite polarityed umbra within the same penumbra, usually within, I believe, the same 1 degree. So it has to be fairly close. It can't actually extend too far away, which, I'll be honest, doesn't happen very much anyway. Classifications, I'd say, are a little more, I think they tell a bit more of a story. Magnetic complexity is important, but the physical properties of the sunspot that you can actually see with the white light, that is this right chart here. That is where you want to kind of gauge what a sunspot is doing. And you first have the first row here, A, B, C, D, E, F, G. Actually, there's no G, it's just H.
That is
This,
interesting. It skips over G.
yeah, which there was a reasoning for it, but I don't remember that reasoning. I'll have to come back to it at some point. These are denoted as capital letters too, but this is to dictate the actual group as a whole. How long is that group? And that's pretty much it. A is in no umbra, nothing, no, it's a unipolar group too. So single umbra, not a developed penumbra, no beta, basically, in the classification. So no other sunspot of opposite polarity to attribute it to. B, you have a positive umbra and a negative umbra. There's usually not very much separation between the two, and there's no developed penumbra. Easy. C, D, E, and F are generally where we see sunspots. C, you have a leader spot in sunspots always. So there's a, let's say, top northern hemisphere right now. The positive end is the follower spot or the leader spot. Then you have a negative umbra that is the follower spot. In this case, if it has a C classification, the leader has a fully developed penumbra, and the follower does not. Those are not very complex as well. And then you have D, where both now have penumbras on both ends and are developed. They have to be under, I believe it's 10 degrees for the D classification to work. So lengthwise, if you take it along the sun, if it's not longer than 10 degrees, it's considered a D classification. E is when you hit between 10 to 15 degrees, and F is greater than 15 degrees. So basically, the longer it is, the more odds it has to be complex. Then you have this kind of off classification H, where you have a unipolar spot, just a positive group or a negative group, no opposite polarity, but it's a fully developed spot. We see those occasionally, but not very often. And then the second group here is how developed is the penumbra. So you've got one system that says how long it is. You've got the next one here that shows how developed the penumbra is. Is it a rudimentary for R? Is it a symmetric for S? Is it giant and symmetric? Then you get H. Or is it giant and not symmetric? You get K. Then finally, you have the distribution of spots within between the leader and the follower. X is unipolar again. So generally, if you see a unipolar spot, it's almost always AXX classification. That means it's simple. It has no threat, and odds are it's not going to amount to anything. O just implies that there's nothing in between. You've got a follower and leader spot, nothing else. I means you have some umbra popping up in between, but there's no developed penumbra in between them. And then C is the most complex one, which C for complex makes sense. You have developed penumbra in between them. So you can use these, the magnetic classification and the Macintosh classification, as this is called. Technically, it's the modified Zurich, and there is no connection to Scott Macintosh, I asked. So Patrick Macintosh was his own person. They have met, though. I'm sure that was a fun story. Yeah. Point is, though, so you have a classification of the magnetic properties and a classification of the physical properties. These are how we determine flare probabilities. Now, of course, if you have a group that is just flaring, regardless of its classification, you assume it has that capability, so it's not the end-all. Just because you have a beta group that's CSO classification does not mean it can't flare big. It just means it's very unlikely to.
Yeah, didn't we see this? I thought that the X flare that caused that October 10th storm was from
It was not an FKC classification, yeah, I can tell you that much. Like it was... I don't remember the exact one. It was not very long, so I'm pretty sure it was either D or E. And then it was I'm pretty sure it was an asymmetric center one, so K, and then it might have been a C at the end too. But I think it was like a DKC group.
Yeah, like it wasn't. It kind of surprised people. It was like that. It was like, whoa, okay. So yeah.
It also wasn't very developed at that time.
No.
And then it developed fast, which is similar to 2673 back in 2017 at the end of cycle 24. It developed extremely fast and started flaring before it even had complex sunspots visible.
Just came out angry.
Yeah, some of them were born screaming.
Yeah, the May one I think was kind of like that too. It just started screaming.
Let's see, May
wouldn't stop.
I don't remember those ones. We're gonna have to go back and at some point search.
3664. I think that was the first one.
Yeah, actually, I do have that shown in the next ones. This chart just is it's a kind of a case study from 69 to 76 showing the probabilities and the amount of occurrences for different classifications of sunspots based on which one they were under and how many M or X flares they had and how many per hour. As you can see, the more complex it is, the EKCs, FKCs, EKI, FKI, those are generally the top four. You're going to have a lot of M flares and usually the higher number of X flares. per group at least. So it's saying that the Macintosh classification really does make a difference when it comes to sunspots, and you know that you're going to want to look after an EKC classification sunspot more than, say, a CSO, as an example. They also contribute to the solar cycle in general, obviously. The whole solar cycle that we have currently, at least, the sunspot number is based off of sunspots. So obviously, they're going to wax and wane. During our solar max, we get a rise and a sharp increase, and during solar minimum, or rather on the way to solar minimum, which we're on right now, it's going to decline. That doesn't mean we're going to be without activity, and I want to stress this in this, well, we'll do the second chart here. We have a sharp rise and a sharp decline, but note that there are still zigzags where it'll jump up very high, then jump back down. A lot of the events, 2003, 2017, or actually 2014, all of those events happened on the declines of the cycles, which is to say that they're not potent, but they're likely not going to be frequent episodes. And then really, this is where I want to take it to JHelio viewer. I have some cool videos to look at.
You and your video.
So solar minimum. We're back to 2017. This is a 30 frames per second, 160 frames, so like basically 6 seconds almost of sunspot activity. 2017 was the decline of solar maximum from cycle 24. This means that sunspots were less often, but the ones that did show up could get bigger and are on the equator, which in this case we have a few here and there. Kind of a big one, kind of a small one, but really not much. This was the very, very end of cycle 24, but still technically in the higher coming down, not the actual furthest down cycle. So as you can see, the biggest one was this one here. If we're looking at classifications, now that's assuming these are the same sunspot group. This is very possibly two groups put together. If we're assuming it's a different group, this is clearly an F configuration because it's giant and more than 15 degrees, which you can actually check with JHelio viewer. 0 to 15, which actually it's even funner because you can put it where you want it to be. So, you know, way more than 15 degrees. And they have developed ends. So I would call this an F, probably K. Well, yeah, F. This would be an FKC. Not a very big one, but the intermediates here, not really that intermediate. And then we get solar minimum. So this is 2020. Now it does take a little bit of time to reconfigure.
I was going to say it's so minimum, it's not there. Gone.
Solar Helio Viewer does not like jumping back and forth in dates, so I loaded 3 very different dates here. So each time you click a different layer, it has to reload that section. So that kind of takes a minute. But the point is, really, is it just not going to load it? I was kind of experimenting to see if this would work, but it might not. All right, well, that kind of backfired. Point is, I was going to show that, you know, solar maximum, you've got a lot of sunspots all everywhere across the whole solar disk. Solar minimum, you've got nothing. And then on the decline of solar maximum, you've got some, but not a lot. And that kind of goes with the cycles here, which if you watched his presentation at all, there's reasonings for that. This is showing the hemispheres as well. So we've got some cycle 23. Oh, actually, let's see. Heliographic latitude. This is where the sunspots appear the most commonly. So 15 degrees seems to be roughly where things appear, which makes sense. It goes down from about 45 degrees during solar minimum, slowly declines in latitude, and not only as it declines in latitude, but it also increases in frequency. So as you would expect to see a higher amount around plus minus 15 degrees. And
So
this shows the peak of that.
just a quick one. This is actually simple versus complex active regions. So SAR stands for simple, and that's the alpha and beta. And then complex is your beta gamma, delta. And that shows that distribution is slightly different. So for simple regions, they just follow the total the sunspot number. And this study in particular, this paper used NOAA data just because they decided to go with it. Complex regions tend to occur a little bit later in the solar cycle, so they do not follow the total number. And they tend to cluster around that 15 to 10 degrees latitude, so not quite close to the equator where we actually have cancellation of the opposite polarities. They are happening a little bit later in the solar cycle and they peak later in the solar cycle. So I do have another slide on the same topic. It's like, where are we at right now? So,
Nope,
do I? Uh,
nope, not on this one.
Not on this one,
So the
but
right chart's showing basically that they have, well, okay, so the left chart's showing the time dependence on that. The right chart is just showing the abundance,
Yeah.
and really they're still all around plus minus 15 degrees for a majority of them. But I like to see that the complex ones are less likely to be seen around 35 and higher latitudes.
Yeah. Actually,
That's what I'm taking away from this chart.
you think about it, it tracks with all these big events happening on the declining phases of the cycle. So
Yeah, and then of
it's
course, yes, on the declines here, you get to see the more increase in the number compared to the
compared to the single
increase
or
in the common.
simple.
I
So
can probably share my screen since you don't have that slide.
yeah, do
Ah,
it. We'll bring that slide up.
We
I
will
mean, the
bring
rest
that
of the
slide
slides
up.
are just the other active regions. I was gonna play guess that
Guess that.
region,
Guess that.
guess that magnetic
Classification.
classification in a Macintosh.
Yeah.
We don't actually
So
have to do
this is where we at in terms of the number of sunspots. And this is official tracking, so that's
I was
SILSO,
wondering
and
where that
that's
was. We get
yeah,
one,
there we
we
go.
got a northern hemisphere peak up in the, well, 2022, and then now we're going
Southern.
we have excess in the
We are
south over the north.
ex exactly. So that's kind of the prime time for complex active regions. We're in that zone, so hopefully we're going to see something interesting. And
Oh, I'm sure.
with complex active regions and coronal holes, it's going to be a mess.
A fun mess. Those are my
Yes.
favorite, personally. I did not really have any other. Again, the rest of them were just
I'll go over some of them. Because it's just
so
fun.
let's see. Here's a basic one. So when I did my analyses of sunspot regions on the group that I had or the page that I have, I would always merge the magnetogram imaging with the white light imaging because this allows you to see not only the details of the penumbra and the umbra, but then you can see the polarities of each of them. So it's very easy to tell delta regions. A lot of groups put the pictures on top of each other, like literally here's one, here's the other. I don't get why. I just merge them. 50% or 25% transparency on the magnetogram, and you're good. Point is, though, this is a pretty simple one. So I would say it's definitely an asymmetric leading umbra. So, and this is a cycle 24 given, or cycle 25. Yeah, that's going to be 25, assuming that's common. Positive for the northern hemisphere. That looks like a fairly developed. I'm going to go with C. Those penumbra are not greater than a degree. I would say CAI or CAK for that one. So it's less than 10 degrees in width, antisymmetric but not giant penumbra for the leading penumbra, and K because it looks fairly developed for the innards if you call this part here developed. It might be I because that looks like intermediate too. That's a hard one to say. And these aren't necessarily factual either. These are opinionated. Now 3664 on the other hand,
This is our
this is the one. Yeah. Gonna be honest, this is one of the more complex ones I've ever seen too. I really don't think I've had a more complex. Like this is a giant delta region right here. Can you see my mouse on that note? Okay,
Yep.
good. So this is a giant delta region right here. There was one that was almost one, but it was a little far apart. And this is where most of the activity was anyway, right around here. But this is the most merging. Oh, and then here too, obviously.
It's nasty looking.
A lot
It
of
just
yeah,
came
this is
out
nasty.
Screaming.
This is a true FKC group.
Good for us.
And then this was a just a review of a slightly complex one. I circled that because I was talking about the potential for delta region. This was not a delta. In fact, I would call this still a just barely a beta gamma for magnetic classification, and it's more than likely a CAC, which is ironic because I don't see much of this. Or DAC. There we go. So it's got fully developed penumbra on both ends. It's antisymmetric for the leading or the follower, and it's definitely got developed in middle penumbras in between. And then 2891 is super simple. This is going to be a beta, and it's going to be easily a CSO because it's not very developed whatsoever. But point is, you get different levels of classifications for the sunspots. That's the idea. And once you learn the classifications physically and magnetically, you can oftentimes tell which ones you're looking at or which ones you should be looking at to see if they are going to flare.
Yes.
And that is my presentation for today.
Well, thanks for that. Now, there will be a quiz at the end, so remember all of those letters. How they go together. I'm kidding.
But most importantly, remember that until we actually have a CME that is Earth-directed,
Yes,
that is
true.
registering at L1, all that magnetic complexity means nothing for we're chasing.
Spot.
Yeah, that's true. But
Regions can fly by and flare on the east limb, and then on the west limb, parting shot. We pretty much used to it this solar cycle. It's just the way it is.
Yeah,
I'm pretty sure cycle 24
that's where they
happened
flare.
that way. There were a few big players in 24 that did the same thing too. So it's sadly not even a cycle common, or not even an independent cycle thing. This is now the second one I've seen this.
Well, did we talk about that? One of those things, the hot longitudes.
Hot longitudes, yes,
that's
that is true.
What this
hot
is.
longitudes applies to Carrington longitudes, so they
But
do
not
rotate
as
with
we
the
rotate,
sun.
though.
Okay.
So
we are also rotating around that. So eventually, those hot longitudes should be facing us. And it seems like they're rotating, and then they're like, skip, and then they go around. Just my biased opinion. We might need to boycott the sun again at this point. I don't know.
Get a new one.
Yes. So anyway, that's our presentation on sunspots.
Margaret wants to know if all of Lake Superior freezes.
Very rarely. I want to. I don't think it did. What was it? I think it was 2013 and 2014 where it was really cold. It got to like 94%, which I think is the highest I've seen in terms of
That's
it
pretty good.
freezing. But that year was wild. Like it was just, I remember because I had to do a lot of driving, and we'd get like a stint of this minus like 30, 40 degree temperatures, and then it would warm up a little bit, dump a whole bunch of snow for it to freeze again. So then you had to drive on all those treacherous roads, and it just did that week after week after week. It was, and that's the last real bad winter I remember, and that was 2013, 2014. But
hashtag get a new sun.
Yeah. So anyway, yeah, but it can get close to completely freezing. But Lake Superior is so deep, and it's hard for it to completely freeze over. So it takes a pretty exceptional winter to do it. Lake Michigan, the other one's not so much because they're warmer and shallower. So anyway, that's my little thing on the Great Lakes region for those interested.
Hi, Vince.
Anyway, yeah, so sunspots are important, as you can see as forecasters. You need to look at them because they kind of preclude what how potential activity. So when you hear people scream about delta regions, that's why. It's complex. They usually tend to be a little bit angry, snarky, throwing flares around. So we like those. But yeah, he said, did you mention the filament eruption? We did talk about that, and then we forgot about it. So we can mention it. There was a filament eruption.
That's about it.
But I think you said...
Do we have models yet?
You said the agencies modeled it as a miss, right?
I'm going to check if
if
MTAM has anything different on that filament.
At the moment?
Nope. They are not showing anything Earth-directed. So we are back to nothing happening.
Yeah, because I do think, like Vincent said, Tamitha made a post about it, so we were just, But I believe, like Tanya said, the agencies, I think, are banking on it missing, so there's the update. And then...
We are really hard to hit.
Filament lifting off at the moment. So
and Hoxt has the filament.
I think that's the one that we're referring to.
Yeah, Hoxt has a filament with 2.4% hits. So that's not looking pretty.
2.4%. So you're saying there's a chance.
Pretty much.
That is technically what's being said.
Yes.
I don't want to see her laugh about it because sometimes we've actually been clipped by these like minuscule things and you're like, yeah, go figure.
And to be fair, filaments are
Yeah.
more difficult to model compared to flare-related CME, so they kind of have their own path sometimes.
Mm-hmm.
So they're harder to track.
Yeah. So.
But so far, there is nothing that's modeled over the last 5 days that's Earth-directed in M2M. And Huxt is showing coronal hole that's approaching, and that's about it.
Okay.
Not very much.
Which means Met Office is pretty much on the same line because that's the map that Huxt is using for modeling.
Yippee.
Hmm.
All right, guys.
We need the moon to go away. We need the clouds to go away.
We need the moon to blow up. What? Okay, blow up the moon. New
Shush.
hashtag.
The moon
Get a
is-
new moon. Get no moon.
The moon is important.
It can just move away a little bit.
Sorry, I got a little
I'm gonna be fine
enthusiastic there.
with that.
You're
Let's not blow anything up.
You're so dramatic. Stop it.
But yeah.
But anyway, yeah. So that's what we got today. Hopefully you enjoyed it. We have Adrian next week for a round
Tuesday
discussion. So that'll be exciting. So it's kind of going to be instead of instead of waiting another week for another one, his availability was Tuesday. That is Tuesday, right?
Yep.
So we're going to do that then, and then we'll dive into some other topic and figure out what we're going to talk about next. But we'll give you guys your Saturday back for Saturday evening. Actually, Sunday for our friends down under.
Good morning.
Yeah. But we appreciate you all being here, and yay. So we'll catch you next time. Let's see if I can...
Bye, everybody.
Bye.